Welcome to the first video for our second unit on Newton's laws. In this unit we're going to start out by talking about Newton's second law first. So right now you should have your Newton's second law worksheet out in front of you. You're probably wondering why do we have a picture of a water skier on here? Just because a water skier is a perfect example of Newton's second law in action. The boat accelerates, it creates a force on the person water skiing, and he accelerates because of that. First, we're going to talk about how force and acceleration are related. Now, letter A, it says, the greater the force that is applied to an object, the greater its acceleration will be. So this just means if you hit something hard, you would make it accelerate more than if you hit something softly. So for the tennis ball, for instance, if you hit it hard, it's going to fly faster. Letter B says acceleration does not only depend on force. The mass, so you're going to write mass in there, of an object also affects the acceleration. If an equal force is applied to two objects, the one with less mass will travel faster. So, for your first talking point, I want you to assume that somebody has hit this tennis ball and this golf ball with the same amount of force. And please tell me which one would accelerate faster. And finally, letter C here says, Newton's second law describes the relationship between force, mass, and acceleration. So we're going to talk about Newton's second law a lot, and it's going to talk all about these three things. It's force, the mass, and the acceleration. And we need a written definition for Newton's law. So it says you're supposed to write Newton's second law below, and Newton's second law states that the net force on an object causes the object to accelerate in the direction of the force. So that's Newton's second law. So all it's saying is if I hit a tennis ball to the right, that it will accelerate to the right, basically. So please write that down. Letter D says, calculating acceleration, we will use force and mass. So below here, I'd like you to write that acceleration equals net force divided by our mass. Or you could just write A for acceleration equals F for force over M for mass. Those are the same thing. Now, letter E says the units for force are called newtons, or N, and are equal to kilograms times meters per second squared. Letter F says if we know mass and acceleration, we can find force according to the following. So we can change this to equal F equals mass M times our acceleration. And we're going to do some practice with that formula in just a second here. Alright, so our first example says, if a ball leaves a tennis racket at a speed of 5,500 meters per second squared and has a mass of 0.06 kilograms, how much force did the racket exert on the tennis ball? So we got to use our equation from the last slide. Now, our equation from the last slide said F equals mass times acceleration. So we look at the problem, And our mass, it says the tennis ball weighs 0.06 kilograms. So we're going to put F equals, and we'll put 0.06 kg times, and that's going to be times the acceleration. So the acceleration from the problem said that acceleration is 5,500 meters per second squared. So we're going to put right here 5,500 meters per second squared. And all we do is punch those two numbers into our calculator, and we are going to get that the ball was hit with 330 newtons of force. So this would be our answer. It's 330 newtons. Now we're going to switch gears. We're going to talk a little bit about where energy goes and why things, stop on their own. They don't keep sliding forever. And the reason that is because of something called friction. Now, friction is the force that opposes motion between two surfaces that are touching each other. So you should write that on the line provided for you by letter A. I'll give you a second to do that. And also you can pause if you need to. The amount of friction that exists between two things depends on the type of surface and the amount of force pressing the two surfaces together. Now there's more than one cause of friction, but we're going to focus on just one main cause of friction. And this is going to go by letter I. And letter I says basically that surfaces are not completely smooth. So even the tabletop isn't completely smooth. Microwelds or bumps on one surface rub together with those on a different surface and slow down an object. So if you look at our picture here, these little bumps here, these exist on every single surface, and they rub together and they stop things from moving. The greater the force on something, the more these bumps interact, so the faster things will slow down. And so for your second talking point, I'd like you to draw a picture of one of these microwelds here, so either this one or this one. And once again, you can pause and do that. Otherwise, I'm going to keep going with the very last one, and that's number 3, and Roman numeral 3 here. And that says that something called static friction is a force that exists when objects cannot move even though a force is being applied. So this boy's pushing on this box, but the object's not moving even though he's applying a force to it. So when you push on a box like this and it doesn't move, it's because something called static friction, and I'll write that out again because that's the next blank, but static friction is stopping you from pushing the box. Now, finally, number 3 here is going to talk about the different types of friction. The first type of friction that we're going to talk about is sliding friction. And the definition for this says that it's caused by microwelds, again, so just like before, it's caused by microwelds. And it's caused by microwelds. Basically, they're breaking and forming over and over again, and it's what opposes motion of two forces sliding past one another. So this guy looks like he's struggling pushing this tire, and that's because all those microwelds, they keep breaking and then they keep reforming. And as he pushes it, it continues to have friction and oppose him trying to push it. The next type of force that we're going to talk about is represented by this lady here, and that's rolling friction. And it says a definition, and what I need you to write down is that this is friction between an object and the surface it rolls on. So an object and the surface it rolls on. So that's what you should write by letter I. So usually this type of friction is less than sliding or static friction because those wheels turn very easily. So that's why you see her trying to move these boxes by using this dolly that rolls rather than just trying to slide them or push them across the ground. The very last thing we're going to talk about is air resistance. So let me get these out of the way right away, and we'll pull up our skydiver here. So like I said, we're going to talk about air resistance. Letter C says, when something falls, gravity is pulling downward, but different objects fall at different speeds. That's because something called air resistance pushes up against gravity, and like friction pushes opposite of an object's motion. So gravity is basically, it's acting and pulling this guy downwards. So that's supposed to be gravity here. Gravity is acting downwards, but our thing called air resistance is basically pushing upwards on this person. So that's going to explain why something like a parachute is going to fall or help a person fall a lot more slowly, because if we look at this parachute, the parachute actually has a lot more area to fall, and so that's going to help us worry about number 2 here, where it says that air resistance depends on basically 3 things. It depends on the speed that something is falling, it depends on the size that something is, and 3, it depends on the shape. So what a parachute does is it has a lot bigger size, and it has a shape that helps it fall more slowly as compared to this person over here. And that's all we have for some notes here, but we're going to do a few example problems together. We're going to do 3, and then you're going to be able to do the last 2, so numbers 4 and 5, by yourself. Alright, so like I said, we're going to go through a few example problems. Number 1 here, it says how much force is needed to accelerate a 66 kilogram skier at 2 meters per second squared. So once again, we're going to use that force equals mass times acceleration from earlier. In this case, we need to know what the mass is and what the acceleration is. Well, our force is going to equal that mass of 66 kilograms, and that's going to be multiplied by 2 meters per second squared. So once we have that down, we can just plug this into our calculator, and we find out that the force needed is 132 newtons. So that's number 1. The second one says, what is the force on a 1,000 kilogram elevator that is falling freely at 9.8 meters per second squared? So we're basically finding out how much gravity is acting on this. Once again, we're going to use force equals mass times acceleration. In this case, it's 1,000 kilograms for our mass, and we're going to multiply that by 9.8 meters per second squared. Okay, so our answer is going to be 9,800 newtons. The very last one is a little bit different. This one says, what's the acceleration of a 50 kilogram object pushed with a force of 500 newtons? So we need to use our other calculation from this front side. Our acceleration equals force divided by mass. So in this case, we're going to have our 500 newtons is going to be our force, and we're going to need to divide that by the 50 kilograms to figure out how fast it's accelerating. And so if we do that, we're just going to take 500 divided by 50, and we'll find out that it's accelerating at 10 meters per second squared. And then for your last talking point, I'd just like you to finish numbers 4 and 5, and then please come up and show me when you're done. And that's going to be it for Lesson 1 on Newton's second law.